Welcome to our fact channel. Our channel has well-known, little-known, and unknown facts. Today we will discuss facts about Sun. Let's start. The Sun occasionally releases powerful bursts of energy called solar flares, which can disrupt satellite communications and create auroras on Earth. Sunspots are temporary dark spots on the Sun's surface caused by magnetic activity, with some large sunspots being visible from Earth without a telescope. The Sun emits a constant stream of charged particles called solar wind, which travels through the solar system and interacts with the magnetic fields of planets. The Sun goes through 11-year cycles of solar maximum and minimum, marked by fluctuations in sunspot activity, solar flares, and geomagnetic storms. Solar eclipses occur when the Moon passes between the Earth and the Sun, casting a shadow on the Earth's surface and briefly blocking out the Sun's light. The Sun's spectrum contains all the colors of the rainbow, but its overall color appears white due to the combination of different wavelengths of light. NASA's Solar Dynamics Observatory SDO studies the Sun in unprecedented detail, capturing high-resolution images of solar flares, sunspots, and coronal mass ejections. Solar prominences are large, glowing loops of gas that extend from the Sun's surface into its outer atmosphere, often visible during solar eclipses. The Sun generates energy through nuclear fusion, where hydrogen atoms fuse to form helium, releasing immense amounts of heat and light in the process. The Sun occasionally forms tornado-like structures called solar tornadoes, which are made of hot plasma and can reach heights of several Earth diameters. The Sun has a complex magnetic field that undergoes periodic reversals, with its north and south poles switching places approximately every 11 years. Solar irradiance is the amount of solar energy received per unit area at the Earth's surface, which varies slightly over the solar cycle but remains relatively stable. Neutrinos produced by nuclear reactions in the Sun's core provide valuable insights into its internal processes, although they are extremely difficult to detect. The solar corona is the Sun's outer atmosphere, visible during total solar eclipses as a faint halo of light surrounding the darkened disk of the Moon. The Sun provides the primary source of heat and light for the Earth, driving weather patterns, ocean currents, and the entire biosphere's energy cycle. Solar storms are intense bursts of energy from the Sun, including coronal mass ejections and solar flares, which can disrupt power grids and satellite communications. The Sun's energy output varies slightly over time due to changes in sunspot activity, solar flares, and other factors influencing Earth's climate and space weather. Solar granulation is the pattern of cellular-like structures on the Sun's surface caused by convective currents of hot gas rising from the interior and cooling at the surface. The photosphere is the Sun's visible surface layer, where most of its light is emitted, appearing as a bright disk with dark sunspots and granules. The chromosphere is the Sun's middle atmospheric layer, visible during total solar eclipses as a thin, red ring around the solar disk. The solar limb is the edge of the sun's disk, which appears slightly brighter than the center due to limb darkening caused by the sun's atmosphere's temperature gradient. Viewing a solar eclipse directly without proper eye protection can cause permanent eye damage, so it's essential to use certified solar viewing glasses or indirect viewing methods. The sun rotates on its axis at different speeds depending on its latitude, with the equator rotating faster than the poles, completing one rotation approximately every 24 days. The sun's core is a seething cauldron of hydrogen undergoing nuclear fusion, converting mass into energy at temperatures exceeding 15 million degrees Celsius. Solar parallax is the apparent shift in the sun's position relative to the background stars when viewed from different locations on Earth's surface, used to measure the Earth-Sun distance. Solar weather refers to the dynamic conditions in the sun's atmosphere, including solar flares, coronal mass ejections, and solar wind, which affect space weather in Earth's magnetosphere. Numerous ground-based and space-based observatories study the sun, including the Solar and Heliospheric Observatory SOHO, the Solar Dynamics Observatory SDO, and the Parker Solar Probe. The solar convection zone is a region beneath the sun's surface where hot plasma rises, cools, and sinks back down, creating the granular appearance seen on the photosphere. The solar constant is the amount of solar energy received per unit area at the Earth's distance from the sun, equivalent to about 1,366 watts per square meter. Magnetograms are maps of the sun's magnetic field, showing the polarity and strength of magnetic regions, which play a crucial role in solar activity and space weather forecasting. Solar dynamics refer to the complex interactions between magnetic fields, plasma currents, and convective motions in the sun's atmosphere, driving its activity and variability. The solar spectrum is a continuous rainbow of colors, with absorption lines caused by elements in the sun's atmosphere, such as hydrogen, helium, and metals like iron and calcium. Solar equinoxes occur twice a year when the sun crosses the celestial equator, marking the beginning of spring and autumn and resulting in nearly equal day and night lengths worldwide. Coronal holes are regions of the sun's corona with lower density and temperature, allowing solar wind to escape more easily and creating faster solar wind streams that can affect Earth's magnetosphere. Observing the sun requires specialized equipment, such as solar filters for telescopes or solar viewing glasses, to protect the eyes from harmful ultraviolet and infrared radiation. Chromospheric lines are spectral lines emitted by atoms in the sun's chromosphere, providing information about its temperature, density, and magnetic field strength. Solar spectroscopy analyzes the sun's spectrum to study its chemical composition, temperature, density, and motion, revealing insights into its internal structure and dynamics. The sun orbits the center of the Milky Way galaxy at an average speed of about 220 kilometers per second, completing one revolution approximately every 225 to 250 million years. Coronal mass ejections are massive eruptions of plasma from the sun's corona, containing billions of tons of material and triggering geomagnetic storms when they reach Earth. Chromospheric dynamics refer to the motions and structures observed in the sun's chromosphere, including spicules, prominences, and filaments, driven by magnetic forces and convection currents. Magnetic reconnection is the process whereby magnetic field lines in the sun's atmosphere break and reconnect, releasing vast amounts of energy in the form of heat and light, powering solar flares and coronal mass ejections. Solar-terrestrial relations study the interactions between the Sun and the Earth's atmosphere, magnetosphere, and climate, including the effects of solar radiation, solar wind, and geomagnetic storms. Solar eclipse paths are the narrow bands on Earth's surface where a total solar eclipse is visible, determined by the Moon's shadow as it crosses the Earth during its orbit. The solar transition zone is a region between the chromosphere and the corona, where the temperature rises rapidly from thousands to millions of degrees Celsius, posing a long-standing puzzle in solar physics. Thank you for watching our video Interesting Facts about Sun. Subscribe, put a like, and to new interesting facts.